There we go. Whoopsie. Wrong graphics. Welcome to Quarkus Insights episode 62. And this time we have Paul Carter Brown, and I'm all alone today. But we'll see.
Hey, everyone.
So anyway, a quick news before we hand over to you, Paul. We got Quarkus 222 out, and last week was 221. It was supposed to be 220, but there was a little bug that ran in, and then we had to do a respin. And 220 was it's a horrible name. 222 was just kind of big bug fixes and stuff. But for those who didn't catch up with 22, it was what we call like a hardening release, where we kind of focus on just fixing any bugs we've got that we felt was so bad. But there's a few highlights that actually happened. One was that we added MongoDB as a dev service. So, Paul, have you used dev services yet?
Yes, a little bit, but not
okay.
part of our normal tool chain, but I have played around with it.
Okay. So the idea is that you can, for anything, we can reasonably guess what you want to do for testing. So, for example, if you refer to a PostgreSQL data source, but don't specify any specific connection, like a test database, whatever, we will spin one up for you if you have a Docker-compatible container. Whether it's Docker or Podman available, then we will start it up. And I think we have Podman, we have Kafka, now MongoDB. I think Keycloak got in there now. And it's quite fun because you literally just by adding an extension and saying, hey, I want Keycloak or I want the Postgres, then you have a testing environment on locally running.
It's pretty magic, yeah. It is.
Magic dev services. And then the one thing that we did in 2.2 was that, which I know you, Paul, you're going to talk about REST Easy Reactive, but REST Easy Reactive we've been doing since, November last year? I forgot. I feel like November, December. I think we announced it. And it's been in experimental state for a while. If you want to get it to be stable and actually be the default, 2.2 is still REST Easy Classic. But in REST Easy, what we did change in this release is that before we had reactive as default, which was great because of the people who wanted to do reactive. But for them, it came from, let's say, classic. They dump into now I forgot the error. Like you are running a blocking code on the event loop. You shouldn't do that kind of error. And we discussed back and forth, and I think, Paul, you were part of that conversation, like, what should we do? And for 2.2, we ended up doing the thing where we will default to blocking, but if your code, like your signature of your method has like uni or multi or is any API that is inherently reactive, then we
completion stages,
yeah, that kind of thing. We will switch to reactive. And we felt that would be the most natural way, for us, it's very important that people get to Quarkus and they get stuff done very quickly. And yes, performance is important, but like usability wins over performance in like experience. So we didn't want, like, let's say if right now 80% of people are doing non-reactive by default, if they go to Quarkus and they'll just be hit with this by default, like, why can't I call Hibernate code here? So now, like, until now, you had to add like non-blocking blocking annotations on. So we flipped that, so now it should be simpler. But still, all your performance reactive specific code will still be in the same context. So it's only if you have like a corner case where you have a method that returns like void or a string that doesn't do any, like it's a very small piece of code, that one you will add non-blocking to get it to be on a full the full event loop. So anyway, that was two. That's two. I'm getting back to speaking here.
Yeah.
And I say John is actually adding comments already here. He's saying, yeah, Keycloak and Redis and Vault. I didn't know Vault was there. Cool. And AppQuery. So all those you can easily get to test with. And and all right, for anyone who's listening, like John Klingen just did, he posted a comment. If you put a comment, I'll put it on. And it was a question. I hope Paul can answer it because I know nothing. And that's about it. So anyway, Paul, let's introduce you. What are you? What? Yeah. Who are you and where are you from?
So, thanks, Max. I'm South African. I live in Johannesburg. I've been around in the tech industry since 1997. Started life on mainframes and moved from there. I've done a lot of different tech and a lot of different organizations, from government work. I was in telcos for a number of years. And in the telcos, we built actually a lot of real-time rating and billing engines, and sort of, all your prepaid SMS and voice and data and those sorts of systems all on Java. So a lot of real-time stuff. And then about 3 or 4 years ago, myself and some others founded Ukesh as a business. And we're really in the game of providing an API-first platform for fintechs and banks and telcos to build fintech and digital propositions on top of. So it's a cloud-native, multi-tenanted environment that anything from payments to QR codes to digital walleting, banking integrations, we kind of provide the single, simple-to-use API that anyone can consume. Obviously, there's a commercial basis behind it, but people can then build platforms, go-to-market propositions on top of our API set.
So that's like
that's really what we're in.
For South Africa, or like bigger, or what's the...
So South Africa and Africa, and looking to the east now as well. But it is a global play. But our focus right now is on the African continent. Where still there's about 80% out of payments are still done in cash. So there's a big market opportunity in terms of digitizing financial services in Africa.
Awesome. Okay.
So if I just want to assume you can see my screen here.
I'll start sharing. Yeah, and by the way, just to give a context, the way I actually learned about you, Paul, was you were doing a presentation, I think, on one of our live tours, live talks, world tours, sorry. And you were showing things you've been doing, and I was like, hey, that's interesting. So that's what the covering we'll try to do today. You'll talk about the stuff that you're doing and how you're using Quarkus. And there'll be some slides, but also you promised me some code, so they'll be good.
Yeah, I'll try and get through the slides as quickly as possible. I think there's only 4 of them.
Awesome.
Great. So I mean, so basically, our product, our API first product, is called Eclipse. It's got nothing to do with Eclipse Foundation or anything. It's just a naming thing. But it's the product or the set of APIs kind of covers all of your usual suspects in a payments and fintech space, from onboarding of customers, digital wallets, cross-border remittance, crypto, card issuing. We do, and a lot of it is we're almost like an orchestration layer in a lot of ways, in that we don't want to reinvent the wheel everywhere. We're happy to partner and to expose other people's propositions kind of as part of our overall API. And we're a B2B play, so we're not building our own go-to-market propositions. We are providing the tech and the plumbing to banks, telcos, fintechs, etc., for them to launch propositions.
Yeah, so you just look like the back-end middleware of how to make sure your front-end app can pay MasterCard or Bitcoin or whatever.
Exactly.
Yeah.
So if someone's building if we take like some of our customers like Chipper Cash, which is a recent actual unicorn in Africa, $1 billion company, they're using us as part of their cross-border remittance and digital walleting. We've got some of the local banks and telcos that we do a lot of work with. We run all of the main sort of QR code payment mechanism in South Africa runs through us. So we're very involved in a lot of it's kind of the company that you're probably using but haven't heard of. So we're behind a lot of the fintech in Africa. So jumping straight in. So in terms of Quarkus in Ukesh, so we were on one of the Java EE platforms or app servers. And I mean, I've been involved in using Java EE, I would say, since 2002 or so, 2003, from the very early days of like Sun One application server in those days.
Long time ago, yeah.
A long time ago, showing my age here. And we then, I mean, moved through. We've used Glassfish and all the versions of Glassfish, and we were using Tommy at a point, and various different Java app servers. And we started getting, just from some of the consulting work we were doing, as well as building out our own platforms, we wanted something that was, just looking around and saying, if we're going to be building this product and we want to go cloud native, maybe there's some other technologies to have a look at. And, we came across MicroProfile, the various implementations, and thought, this looks like the way to go. And then we came across Quarkus as part of that. And then after some POCs and testing different things, we decided to standardize on Quarkus. And that was around beginning of last year. That we...
You picked up Quarkus 1.3 or something like that.
1.3, yeah. I think when we were experimenting, I think it was 1.2 or 1.3, and then by the time we went live at first, I think it was 1.4. Yeah.
Okay.
And we pretty much lockstep. In fact, I mean, all of our sandboxes already, etc., is already on 2.2.2. So we we look forward to everything as it comes out the box. We don't like legacy. So we like to keep up to date. So we're on Java 16, Quarkus 2.2.2.
So you're gonna move to Java 17 in like 8 days?
10 days, 9 days. Yeah, can't wait. Yeah.
Awesome.
So we learned. So our first production services went around April of last year. We have over 500,000 lines of code running in Quarkus. I'm not going to go through all the extensions we're using, but we're using quite a lot of them. Yeah. And
but it's not in one. It's not in one app. It's like multiple small, I guess.
So the architecture is it's API first. So if you just have a look at this picture here, we're basically it's on AWS, but we do have deployments of kind of our architecture that run on Kubernetes, just plain Docker, you name it. And it's a API gateway which we've built on top of Quarkus and REST Interactive. And that API gateway is kind of the entry point of all REST requests. And then we load balance across a farm of microservices, which are sort of functional domain-driven services in the payment space and user management profile, you name it, sort of 10, 15 odd different microservices. They're not, you get, there's a lot of talk about how micro should your microservices be. So we're not, creating one microservice with 100 lines of codes. They are,
macros.
Cover a full domain, so like a payments domain or a user management domain or something like that. Each microservice covers.
So,
yeah.
Quick question. So you say you have a 500,000 lines of code now. Do you know how much you had before, or are they not comparable? Like, do you have less, the same, more?
So, I mean, it's constantly growing as we're adding functionality and integrations. So it goes up, and then every now and then we get the fun is often always deleting code as you find a new framework or a new optional way of doing things. So the code base has been growing progressively because we've been adding a lot of functionality.
Got it.
Yeah.
Okay.
So and then our main Eclipse platform is running in AWS. We're using a lot of different open source frameworks. MapStruct, I'll show you some of the stuff we do with that. Hazelcast is quite integral to what we do. we deploy in AWS ECS. And yeah, everything it's JVM. We're not using native. So it's JVM Quarkus in Docker running deployed on ECS with auto scaling and all those wonderful things. And persistence is a mixture of Mongo and MySQL.
Got it.
Okay. A bit around. So when we migrated to Quarkus from Java EE, just some of the results. So we were facing a boot time of around 40 odd seconds, with a heap of sort of a low level. The heap after you'd been running wouldn't drop below sort of 120 odd megs. We migrated to Quarkus. Boot time was around 5 seconds. And we could run our platform on a 35 meg heap. So just the light, the weight of Quarkus was just so impressive in terms of functionally it could do everything we were doing and more. But from just a boot time, developer experience, resources perspective is a lot lighter.
Yeah.
Docker images are a lot smaller as well.
Yeah. And which image space are you using for your stuff?
Sorry, what? Sorry.
Which space image are you using? Just the one we put in there, the UBI, or?
No, we're using Adopt OpenJDK 16.
Okay, got it.
Yeah. Then and just some other anecdotal stuff. So around the community, I thought Georgios was going to be on this call.
But he said hi, by the way. But he's doing a world tour at the same time. So that.
Okay, great. So I mean, this was just on the left. It was interesting. I mean, it's still the whole open source community amazes me, and this was just one example around Quarkus. Is we were trying out REST Easy Reactive, so this was in December of last year. Found a bug, and I think it was on a Friday, and within an hour or two, Georgios had already pushed a fix, and it was now working. So it's that kind of thing. It's there's just so much care around and pride in terms of what you guys do, and I think that shows in the community and your responsiveness and that sort of thing. So hats off to the whole team there.
Yeah, George is very crazy, but so we try and help.
In terms of performance, I mean, I did, so when we moved over to Quarkus, we're seeing about a 30% increase in throughput on the same hardware. Now with REST Easy Reactive, probably about 50% more.
So 50% from the baseline being Java EE.
Yeah.
Okay.
Yeah, and with less resources.
Yeah, so I'm sure. Well, it depends on what you guys are doing, but I'm sure George will ask I was hoping REST Easy Reactive would give you more, but I guess it depends on your cases. But yeah, we do see about 20 to 50% just from REST Easy Classic to REST Easy Reactive. Yeah, these numbers add up. So
yeah, I mean, it depends what you're testing. If you're just testing a ping service, then obviously the platform is going to play a big role. But if you're doing full end-to-end to databases, etc., then there's a lot of latency there that you can't speed up light.
Are you doing reactive on top of REST Reactive, or are you using imperative?
Bit of a mixture. So most of it is still imperative. I think from previous Quarkus Insights I've watched, I think you're probably on the same page that the whole reactive programming model is difficult to follow, and it does make things a bit more complex. So where something really needs to be reactive from a latency perspective, we do that, but most of it is still more traditional.
Yeah, that was cool. And that's the thing is that it actually took me like a few rounds to understand what REST Easy Reactive actually is doing. It's like REST Easy Reactive is reactive at its core, but you can use it as any other. It's all plugging if you want to, from your perspective. But if you want to and go full reactive, then you can, and I think it's
and there are huge benefits in REST Easy Reactive, even if you're not going the whole reactive paradigm. Like these performance tests are still blocking, so this 50% increase is still blocking. and it's still doing, persistence, etc. It's not just, we're using REST React mainly in a blocking paradigm.
Yeah, right. No, so it's just you're benefiting from the fact that we re-implemented the core of REST in a reactive way, and we skipped a lot of stuff we didn't have to do, and then we get this benefit. So very nice.
Yeah. Around performance, I mean, this is a simple ping test that we were doing around just a simple end-to-end REST call, and this was actually on my laptop and running right now, 135,000 requests per second. So it's yeah, it's decent. Like I say, yeah, if it's slow, it's not Quarkus. it's your code. Its performance is pretty impressive. In the time that we've been running our Eclipse platform in production, which is pretty much a year now, we have had 31 seconds of downtime in almost a year.
That's nice.
That was a configuration problem during a deploy. which
I was going to say, the 31 seconds, was that us or was that someone else?
Not a single problem with Quarkus. So it's from a people say, oh, it's enterprise software and this and that, and I, with everything I've seen in my career, I mean, from a Quarkus perspective, it's stable, it's resilient, it's very impressive.
And you guys deploy when you deploy, so average one deployment. So that means like every 2 days, at least one of your services will redeploy of some sort.
Yeah, if not all of them.
Got it.
Yeah.
Cool.
And then compute costs, obviously from an AWS perspective, with Quarkus being lightweight, I mean, most of our spend is more around databases than compute.
Yeah, so that one, can you? Unfortunately, for my screen, I'm not sure if what's in the labels down there.
Okay, so the purple down here is RDS, so that's relational databases. Okay. And then this is Elastic Container Services, which is really compute. So consider this to be compute, and that's tax. So our compute is almost the same as the amount of tax we pay in our production environment. So it's the RAM savings and etc. With the smaller heaps really pays for itself.
So if you made this one for like Java EE, that middle turkey screen thing would be bigger, is what you're saying.
Mm-hmm. Yeah, quite significantly. Yeah.
Okay.
And then just probably about 6 months ago or so, I sent out a monkey survey to our dev team, just touching base with them on they were all on Java EE, and quite a few of them, because we've been growing quite fast, a lot of our developers were coming from a Spring background. So we did a survey. This thing here is around how would you rate the development tooling compared to past environments. And pretty much everyone was either better than I'm used to or much better than I'm used to. And that plays down to the whole development experience of doing, live reloads and the testing experience and everything else of Quarkus, which is key, to the dev team.
Are you guys using the continuous testing, the console we have in 2.0?
Not really. It's our tests are mainly integration tests that cover everything end to end. So it makes more sense to run them as part of CI and CD.
Oh yeah, but it's so. What you're saying to me is that what you're responding here to is basically what the experience we had since early on with 1.0 with the normal reload. You guys haven't even tried. You probably have, but you right now it's not even a continuous testing that you've been doing.
Yeah.
And by the way, the continuous testing doesn't mean you have to run all the integration tests. It's just anytime you do a change, you can run a set of tests that you can scope down to. Hey, I only want to run the Paul's tests, not backend tests. And then you get a feedback, and that means you. Right now, when I do Quarkus apps, I just start up Quarkus and I just let it run in a terminal, and then I just write code, And then at some point it starts yelling at me because I did something wrong. I'm like, okay, then I can.
Yeah, it's like you've got this parrot on your shoulder telling you what you're doing wrong.
Yes, and hopefully something can tell me about it. Right? Yeah. So Paul,
Yeah.
I love the slide. That I love that you. Oh, but what was the last one you asked for? Right?
How would you rate your development productivity compared to past frameworks? And again,
okay,
higher,
and then,
much higher. Yeah.
cool. Because that I love the love, that's for sure. But is there anything that doesn't work? Like anything you can learn from or improve, or are we just perfect?
Sure. That's a tough one. We don't use native. And I don't know if this is really a downside of Quarkus. I think it's more a GraalVM thing and just the state of where it's at. But we've tried to build our entire framework natively, and it just doesn't work because when you start bringing in weird APIs you need on the side, like Apache POI to generate Excel documents for reports or this or that.
Yes.
Those weird things, and maybe some auth toolkits because you need to parse a QR code into vector graphics, or I don't know. There's just always those weird edge cases that don't work. So in a simple service, it does go native, but generally we don't. And when we did try, the build times were just far too long for our liking. So we've stuck to JVM, but we'll monitor and see how it goes. Maybe GraalVM will get to the point where it does work.
Yeah. No, as well as the two things you bump into is, one is the compile time, which is we think, or at least talking to Graal, we can improve somewhat, but it will always be slower than normal Java compile. Because there's just, it has to do a closed world assumption, so it has to go through a lot more that you can't just, like, one reason why you can compile Java fairly fast is you can assume a lot of things and depend on things that are already kind of compiled. Where in GraalVM it has to go through a lot of things. So that's a thing, and that's why a few people I've talked to start using Quarkus and they think they have to wait for native compile. It's like, no. Native compile is something you do like once locally, just see if it works, and then you like the CI do it as its last step before you're testing. But another one is it's a good point, is one of the challenges is that with GraalVM, stuff like AWT has issues. Not all of AWT, but some of it. But it's interesting because you're actually the first one who actually pointed out, hey, PDF, like Excel, not Excel. When you want to generate something with a graphics, you have to access AWT, and AWT has to get the fonts of your system. But right now, the way GraalVM works, that will be what's available when you build it, not when you run it. There's this kind of mismatch. But that's something we actually we can fix to some extent. So if you have those kind of asks, you should just open an issue if you don't have already. But I assume for you guys, you would, if you would do native, you have the generation stuff in a Java process, and then the others in native. You could do that if you want to. Save time, So
I think it's a matter of trying to keep it simple. That the less deployment models and things you have, the easier things are to manage in production. So we just kind of standardized and said, let's just use JVM.
Yeah. No, and by the way, there's nothing wrong with it. Like many people think Quarkus is native, but that's not. Quarkus is much more, as you just said. It's just pure Java. You're getting these benefits, and with native you go even further. But it's what's it called? It's a balance, right? You lose something. You have to spend more time building. There'll be less dynamics. Not dynamics. Like some things will be harder to debug because you don't have the full JVM and that kind of thing. But it all depends on your business case. But you see that for your case, it's enough. So
yeah.
Okay. Cool.
Right. So
are we on
no, that's it from the slide world. I will kill that. I think let's get into a little bit more fun stuff.
I see. I got a comment here from Didi. It says native image and Datadog as a Java agent. It's still not there. So going native is really, really hard. Yes, so Datadog is like a general logging what's it called? Distributed
cloud
logging.
logging and telemetry, etc. Yeah.
And the way their agent works is that they hook in at the agent level to introspect certain cut points and then log it out. That works great in Java VM, but in native they will have to do more. Actually, we should go and talk. I know I have some emails from them about how we do this, because the way to do this actually is that they write a Quarkus extension that instead of doing what the Java agent does at runtime, they should hook it in during build time. But they should have access to the same thing. But I know, they'll take some time before everyone can do that.
Yeah.
So, but yeah. Okay.
And maybe also, you had mentioned just other things to improve on. I've always wanted to write an extension and just never got around to it, because the learning curve, I don't know, it just seems a bit like a dark art to me. And it seems like
Yes.
the Red Hatters and the rest of the team really, get them out there. But as someone outside of that, I've watched the Insight videos on creating extensions, and I almost wish that there was almost a little a simple extension, that maybe there was a YouTube video saying, let's build an extension that does this and this, and build it up from scratch with a Hello World extension. Something like that would be great.
I hear you, and we actually do have I think the banner we have in Quarkus, we have this banner thing that comes up in the beginning. That's like the simplest extension I can think of. It ended up being not but we actually have an example, and we should probably show that more. And yes, we definitely can see some of that documentation should be improved. It's on the roadmap of doing there, but yeah, it's a good point.
But at the same time, though, and I've seen discussions in some of the mail groups and things, is that you don't need to build extensions. You can just use libraries, just like you would with any other Java framework or technology. You can just add libraries. The extensions is more around making it feel native to Quarkus, and then obviously if you are running GraalVM to do all of the AOT stuff.
The extension does two things. One, it allows you to hook in and do what's needed for that library to work in native. That's one thing. The other two is you can participate in the hot reload. So that's why, like, if for example, Flyaway and Liquidbase, you could use that with Quarkus without the extension. But you will not, like, when you do a reload, Flybase and Liquidbase would be behaving weirdly. Either they would not participate at all, or they will like restart every time, and you'll add like n number of seconds to your reload. But yeah, if you're losing stuff like I don't know, a MapStart might actually be one that we need an extension for. But any like API framework library that just does something for you at runtime, yeah, you can just use that straight out of the box. Shouldn't be a problem. So no.
Yeah, I mean, we use Hazelcast extensively. We don't actually use the extension, because the extension came out after we had migrated to Quarkus. So we went through the pain of getting Hazelcast and dealing with hot reloads, etc. And you can solve those problems without an extension, but obviously it's not as optimized as using extension itself. Yeah.
Right.
Okay. So I thought what would be useful is just to take the audience through what's how we use Quarkus. So I'd mentioned earlier, so kind of on the slide here, how we have an API gateway and then we have microservices. And I've created two little sort of hello world microservices, which follow how we do things. It's literally how we do them. It's not just saying it's the right way. And just the design decisions we took in building our microservices. And then once we've gone through that, I can boot them up and just do a bit of a demo of how our API gateway uses them. And then if we have time, I can do a bit of a concurrency test to show the benefits of Rest Easy Reactive by trying to destroy my laptop in a ball of flames by opening a lot of connections all at the same time.
Well, hopefully not more than the restream can get the picture through.
Yeah, hopefully.
Yeah.
Okay. So let me just.
That is tiny.
Oh goodness. Okay, so let's just go here.
Yeah, just a little bit.
18, is that a bit bigger? Still bigger
big,
20,
go bigger.
24.
Now I can read it. So hopefully I'll do
okay. Yeah. That better?
Yes.
Okay. So yes, I use NetBeans. It shows my age, but I love it. So I've tried everything else, and it still doesn't compare.
Is that a South African thing? Because Philip has the same thing. He is also a NetBeans guy.
I don't know. I don't know. I've tried. I know it's not hip and it's not cool, and I've tried all the other ones, and I just NetBeans for me is just so much better. But it's such a personal preference. Like I say to my team, in our team, you use whatever you're most productive on. It really doesn't matter. So I've got two microservices here. One is a car service, and I'll just have a look at that. I'll ignore these other ones. And this is as simple as saying you want to create a car. I've got a little database here, which I can show you, which probably is too small, but I have a car table, and the car table has got a auto increment as an ID. It's got a manufacturer, a color, and a year. So really simple, stupid CRUD interface to add, update, read, etc. And this is an anemic service. It doesn't do much from a business logic perspective, but consider that our real world services aren't anemic. They do lots of business logic. It's not just a matter of reading and writing to a database, but this kind of shows the core concepts of how we do things. So the first design decision we took is each of our microservices is actually broken down into two different modules. We have one which is the model, and the other is the service itself. The model being the Java classes that make up the interface, the REST interface. So in this case, we have a car as an example, which is our model, and that car's got the ID, manufacturer, color, and year. Okay, so right now it's pretty much what the database model is, but it needn't be that. And we have this in its own model, well, its own package, so that we can push this to a Maven repository, and then clients or the service can pull in just the model. Okay. So they can use strongly typed models without having to build anything from Open API or anything like that. They have all the model classes, and if we go and do a breaking change on a microservice and then someone points to that new version, then their code will no longer compile because the model's changed. Maybe they're referring to saying it doesn't exist anymore. So that was one of the choices we made, is split out the model and then the service itself. Then in the model, if I just open it here, the two things around a model is one around how do you generate entities. So if you're using JPA, you get the whole database first or entity first. I've always preferred database first, just using database tools and creating a structure in the database, and using the database data types, etc. just kind of feels right. So what we typically do is go into the database and make schema changes in the database. So if I go here, I don't know if this is visible, but if I'm just going to add a column on our car table and just say a type of the car, so that it could be like off-road or whatever, we can leave it as varchar 45. And I say apply. So I'm just changing our model. So we've added another column. If I build this project, we use Hibernate reverse engineering, which then points to the database and generates the entities accordingly. So if I go to generated sources, here is my car, and you see it's got type now. So our database model, kind of the master is a database we run in AWS that everyone has access to. And if you're writing new microservices or whatever, you set the model up there, and then whenever stuff builds, it will pull the model from that almost template database. So that's, in terms of generating entities, that's just how we do it. And then the other side of the coin is when we're exposing our REST interface, we didn't want to have to go and write all of the POJOs and bean validation of the REST model. So if you've got a car as a model, how do you write those POJOs? And this approach kind of comes back from the SOAP days and using beans and JAX-B to generate Java, and it's kind of old school, but I haven't found anything better. And I wish maybe someone can point to a better way of doing things. But what we're doing,
what are you using as a base? That was my
question. So what we're doing is we actually have an XSD, and the XSD has all of the model classes, and an XSD with JAX-B can do very complex modeling. So you can have complex classes with subclasses and lists, and all of the data types are supported. And you can basically build out a model of your interface and the classes of the interface in a single XSD. So for the car service, as an example, we've got a service.xsd in which we have all of the model. The entire model is explained in this XSD. And when it's built, it then generates our Java classes.
Okay, so you added a column to the database. That doesn't pick, you have to go manually add that.
So it doesn't, because in a typical service is not going to be an exactly one-to-one mapping. You're going to have business logic and differences. But what I would do here is just go and add and say, okay, we do want to actually use this type field. And we want it provided when you add a new car, and we want it provided when you get a car. Okay, and while I'm there, I'm just going to go to the database and just put in some data here, type, just so that when we do try it,
you get something.
We get some data. So let's just do that. So now, having added type, if I again just rebuild the project and we go back to
you put text in the
sorry.
Yes, I was just wondering what will happen.
Okay, let's just do that again. Okay, so now it's rebuilt the database model in this model, and there we've got type. Okay, so one of the other things, so this is where we got a bit gnarly and said, well, how do we do bean validation, because XSD doesn't actually cope with that.
So so when you added here, was it Quarkus picking up the changes and rebuilding, and you hook into that?
No, so this is I'm just kicking off a Maven build, and in this POM of this model, we have the Hibernate reverse engineering plugin, as well as the JAX-B code generation plugin.
Oh, you do? Awesome. Sorry, I wrote that one, so I was like, that. It's been a while since I've seen it in live. So that's
okay. So and then what we did, and this is really old school, then, is actually wrote a JAX-B plugin, which parses, and we had to use comments because JAX-B has to use the
it has to be outside
the XML schema, and then it complains and says it's not obeying it. So what we've done is a real hack, but it works, is within comments put in our own basically what are the mixture of open API annotations and bean validation annotations.
It's just in XML, you should be able to have a separate namespace you could use, right? Or does that conflict with?
It doesn't like it, because then you know, if you wanted to go and put attributes, but even, you see, if you put a different namespace within their namespace, it complains. We tried all sorts.
Yeah, it has to alive it. Yeah. Okay, yeah.
So
just to give a color, because what you're showing now is this is a very common case, right? Where you don't want, like, you have a database, you want to generate, you don't want to hand edit it, but you do want to have some control, which is what you have here, and you add your own whole tool chain around it to save your time, which is a perfect valid thing to do. So just to get this, actually something we discussed, because there is actually, this is where I'm like, hey, you should have a Quark extension for this, because at Quark there is actually support in Quarkus for an extension to literally just be a code generation step. So our Coquito extension does that, and our gRPC extension does that. So gRPC is the same kind of thing, where there's a text file, I forgot now, there's a separate descriptor for the protocol, and you change that, and we didn't want you to have to, as you do now, like run a build and pick it up, and so now there's an extension that see the changes, and in dev mode will do what you've done now, but it will just participate in the Quarkus lifecycle. And you should be able to do the same thing for this thing.
Yeah.
But I know you have it, but the other part is we do actually want to have a way to be API first. Like if you have a Swagger document or something that says, "Hey, this is our REST API," and have that as a way to generate a type same thing. But it's still being discussed. But
it's those, the two ways as some people prefer to do. Database first, generate entities. Others the other way around, and the same thing applies. Some people like to generate an open API document and do code generation. We've chosen the opposite approach. We document on the APIs, and that generates a Swagger.
Sure.
Okay, so we've got these annotations to put descriptions on things, bean validation, etc. And then when this is built, our plugin pulls through these things and augments the model to end up where we have the bean validation messages and the descriptions, etc. And these then play into two things. The one is in terms of the Open API, because it's pulling in the Open API annotations, and then also bean validation. So within this single file, our entire model is explained and described and validated in one place. So we don't have 100 POJOs sitting there that you need to model. Okay,
sure.
So that's the model. Then the service itself actually depends on the model, and the service has a few different parts to it. So we have, for example, the cars resource here, which is pretty much JAX RS using REST Easy Reactive. And for example, get cars by manufacturer, offsets, limits, etc. for pagination. Then our typical thing is the REST services, we keep them really light, because in years to come, some new interface type will come out, and we don't want to have all our logic sitting in the REST interfaces. So the REST interfaces call off to a service.
Are are we looking at something that's generated here, or
no? So this is type code.
Okay, so just I know Georges will hate me if I don't say this. You don't have to have the query parameter there, right? That is.
You don't have to. Yeah, there was a discussion around that and using some REST Easy Reactive labels. We can actually, you can just say it. I think it's query string or something, and then you don't need anything here, and it pulls off. It uses that label instead. Yeah.
Yeah, and I think even if, well, I'm not a fluent, but if you have in since Java 8, you can tell the compiler to include the name of the parameters, and therefore we use them when available. Right? So you don't have to say query param offset is offset. You just say query param, and I have a feeling you don't even have to specify query param. Just be, if it's not there, we assume it is. But that's Georges knows that better than I do.
I'll play around with that and see.
Yeah. Well, at least I'm 9, so you don't have to have offset or limit, and you don't have to repeat that for sure. So,
okay. We use sub resources a lot. So in our typical REST interfaces, we will have the plural for whatever the thing is that you're dealing with, and then we'll have a sub resource, which then is the singular. So our sub resource in this case is the car, and the sub resource you're dealing with a single car. So it's a get of a specific car, a update of a car, and a delete of a car. So we kind of follow that model, and sometimes we have quite deep hierarchies of sub resources. In fact, if I jump to kind of the swagger of an actual Eclipse API, you will see that it's got a lot of APIs and a lot of resources and a lot of depth to them.
Cool.
So yeah.
Paul, just so you know, you have about 9 minutes left.
Okay,
so
goodness. Okay, so let's jump in. So this is the car service itself, which the REST resources use. We use map struct for mapping. So you will see that I've written that change to the type, added type, and we don't really have to worry about even updating any of the code. I've updated in the database, updated in our model, and it'll just flow through because it's got the same name and everything. So let me I'll just build the car service. And let's quickly just start it here. Okay, so I've just got a little bash script that basically just runs. We'll start that Quarkus service. We are, as I said, we use Hazelcast a lot. Most of the boot up time is around Hazelcast. So I actually have another microservice, and I've got an API gateway running. So here it actually ended up syncing with the rest of the cluster, discovering them, and now we kind of have this data mesh of microservices that are all aware of each other, and they're all aware that that they're supposed to be behaving nicely amongst each other. If I now jump over here and just do a curl to get the cars. Sorry, let me call directly into the service. Port. Sorry. Need to see what port I started this on. 1001. Oh, that's why. Okay, so here we've got a car back. We're asking for everything when manufacturers BMW, and you can see we've got the type has come back as well. And we can go and say we want a specific car. We want car ID number 2. Sorry.
Oh, I'm missing a
and we get car 2 back. So that's a basic REST service, how we do our database stuff, how we generate the models, etc. And if I were to go to this URL and just put docs in front, then we get our open API, and you can see here we've got our car, and you can see that the descriptions and everything in the model are all coming through from our XSD. Nice. So everything from a documentation and everything else is taken care of.
So basically using, the way I see it is like you have Quarkus as your base, and then you, let's say, code generates the middleware, like middleware, your business layer, and then you generate like the Swagger stuff, and you just use the Swagger extension to expose that thing, and you're all good. Yeah, and thing is cool. Awesome.
Okay, let me just do this again. So one of the other things, so we've written some interceptors and all sorts to do nice logging, so you can see when requests come in, and you can see the whole request and everything, and the responses and all the timing, etc. And then we've done a similar thing with with using Jaeger and Quarkus and open tracing, where the requests will end up in Jaeger. So if I just do a request here, sorry, port, and I jump over to Jaeger quickly, we can see here is our request coming in. This one I sent to our API gateway. So it actually shows the request coming into the API gateway. It shows the calls that then did to the downstream microservices and the responses coming back. And then you can also see in the downstream microservices the requests that they got and the responses they sent back. So sort of full visibility of the entire call chain, and even down to the database calls. So if you go to the logs here of the final microservice, you can see the SQL that was ran and how many rows returned and the timing of those.
Very nice.
So from a visibility perspective, we don't like to use logs, especially in a PCI compliance environment. You don't want lots of people having access to production. So we use Jaeger extensively from a tracing perspective.
Okay.
Okay.
And this is, so just all the lower stuff, is that actually something you added, or is that actually part of the Quarkus?
So it's stuff we added on top of Quarkus. So in top of the hook and points that you get around the interceptors and filters and things that you can do. We used to use servlets, so we used Undertow as well as REST Easy Classic. And we were using servlet filters to do a lot of things. And then when we moved to REST Easy Reactive, we decided, well, let's cut out servlet entirely, remove the Undertow extension from a performance and lightness perspective. So we actually have nowhere do we have JavaX servlets in any of our code. Everything is based on JAX-RS, interceptors, etc. Yeah.
Cool.
And then quickly, I forgot 1 minute. So one of the things with the API gateway is when I said, the services boot up and they communicate over Hazelcast. If I boot up, so if I send a request here, where was I? So sending a request to this path here, QI conductor, that's actually going to our API gateway. And then the rest of it is saying, well, let's go to REST v1 cars 2. Now, what happens is whenever a microservice boots up, it connects into the Hazelcast cluster and publishes all of the REST endpoints that it exposes. So that when the API gateway gets calls, it will say, oh, I know of a service that is prepared to service REST v1 cars, as an example. So if I shut down my car microservice here, and I do a request asking the API gateway, please can I have cars, it says there's no possible services to pick from, i.e. I don't know of anything that can handle that URL. If I go and boot up a microservice, it then connects into the Hazelcast cluster, does all the service discovery sharing as to, hey, I'm here and this is what I do, so that when you now send requests to the API gateway, it now knows of a service that can do that. So that's how we kind of enable in a non-Kubernetes environment still have the service discovery and resilience and load balancing, because if I boot up 50 instances, the API gateway will load balance across all 50 of them. And that's just how we've deploy things. Yeah.
Sure.
Okay.
No, excellent. So people are a bit quiet today. We've got a few comments, but no questions yet. But they like what they see, at least. So that's good. But you got anything else? You have like 2 minutes, but otherwise.
So yeah, what I can do quickly is I have a thing here which will send 5,000 concurrent requests to in our car microservice. I had something here which will sleep. It actually returns a uni, so it uses REST Easy Reactive in a non-blocking way, and it'll sleep for however long you tell it. So this is like your worst case scenario of saying, let's send 5,000 requests to Quarkus through our API gateway, and then our API gateway in turn calls into the microservice below it. and each service will sleep for 10 seconds and then respond.
Okay.
So you got 5,000 concurrent requests going on, and I will.
Oh, okay. So I was just saying, before you start that, if you suddenly disappear, let me know that Quarkus overloaded.
Yeah. So let me.
It should be fine.
It should be fine. So let's just see here. Okay. So that's running, and then at the same time, I'm going to run concurrency of 10, a load test against getting my cars. At the same time as doing 5,000 concurrent requests that are sleeping for 10 seconds. And you will see, let me kick off my, let me just start it again. So there's my 5,000 concurrent requests. There's my load test kicking off. And we'll just wait for them to finish. So the load test is going to finish after 10 seconds. So there's 700 odd requests per second. I was getting several thousand, I think, without streaming at the same time. But
yeah, streaming is gonna.
It's still working. And you could see, I mean, we don't have to wait for this result, but you can see from the previous result that there was not a single failure. And so there again, so all the requests sent. And a maximum response time of 13 seconds, which shows that there's no queuing happening. There's no thread pool, that these are now going into a queue waiting to be processed, or else you would see, maximum response times of factors of 10 seconds. And this is all, built off the back of REST Easy Reactive and the non-blocking I/O that it gives you.
Exactly.
Which from us as an API provider is core to our business, is ensuring that we can deal with that sort of concurrency.
Yes. And that's the, let's call it classic middleware. Before didn't have the ability, well, they did, but they didn't do it. But with the stuff we've done in REST Easy Reactive and the other reactive stuff we've done, we're literally down to, like, you cannot, like, maybe you have like a dedicated library for your specific stuff, you can do it faster, but for anything else, this is like as fast as you like physically can do it on a Java VM. So that is very nice. Happy to see that actually works for you. That's good.
Yeah.
Cool. Anyway, we reached the hour. We didn't get a question. There was someone from I'm not sure if you know. Someone said hi. Where did he go? Well, Sabello.
Sabello, yes, he's part of our team.
Got it. So yeah. So anyway, Paul, super happy that you got here and showed it, and I know you had your corona that delayed you, but that was good you come through that
good
too.
To get that over.
And really appreciate that. I really like the fact that you're not only saying that you did it, but you also ask your developers, and they came back saying, yeah, we actually do like it. So that was a real nice plus. Hey, Paul, I'll say thank you to you, and
thanks very much.
Shut down here, and we'll come back next week. Thank you.
Good. Thanks very much for your time, and thanks to the Quarkus